time we had done circular motion, uniform circular motion. Okay. So today I am going to talk about non-uniform circular motion, and you have to be very, very attentive to understand this. Although the difference between uniform circular motion and non-uniform circular motion is very minute, very, very small. मेरा वॉइस क्रैक कर रहा है क्या? हेलो हेलो, नहीं कर रहा है ना? अब इन लॉग आउट करके लॉग इन कर. So even though the difference between I will say UCM and NUCM is very, very small, but the small difference actually uh, uh, maybe it will make things complicated for you, right? But if you grasp the fact that there is this small difference which is existing, then there should be no problems. So in non-uniform circular motion, we have a particle again going around the circle. In our syllabus, radius change is not allowed. Okay, so we will not be dealing with spirals. And as I told you last time, third axis पे force भी zero होएगी always. अगर थर्ड एक्सिस पे फोर्स नॉन जीरो हुई तो ये पार्टिकल का मोशन हेलिकल हो जाएगा. एंड हेलिकल मोशन इज देयर इन आवर सिलेबस, बट that we'll be dealing with when we do magnetism in class 12. So for the moment, we have a particle moving along a circle of radius r, right? But this time the particle is not moving with a constant omega. So omega is not equal to constant, and therefore the speed of the particle is not equal to constant, right? So these two things that I have written, they are the feature of non-uniform circular motion, right? So if you ever see a particle moving in a circle whose velocity is changing, right? In fact, जो मैंने statement बोला वो थोड़ा गड़बड़ है, क्योंकि uniform circular motion में भी the velocity of the particle keeps on changing. Magnitude of the velocity never changes. So if you see a particle executing a circle for which the magnitude of velocity or the speed changes with time, or if you notice that omega changes with time, that means that you are dealing with non-uniform circular motions, right? So how do you deal, what do you do when you have non-uniform circular motion at hand? Everything remains the same. Step one, you have to draw the radial axis. And then step two, you have to draw the tangential axis from the location of the particle. So the origin is the location of the particle. And then you draw your FBD. You draw your FBD. I don't know. F1 force इधर लगा है, F2 force इधर लगा है, F3 force इधर लगा है. And let this be theta 1, let this be theta 2. So in this case, we have F2 cosine theta 2, F1 cosine theta 1, F1 sine theta 1, F2 sine theta 2. Right? And then what you do is you write that along the radial axis, you get f2, you get f2 cosine theta 2 minus f1 cosine theta 1 is equal to mass into radial acceleration is equal to mv square by r is equal to m omega square r. But here remember that the v and omega, they are variables now. Okay? They change with time. This means that the centripetal acceleration or the radial acceleration itself keeps on changing with time. Okay? And then along the tangential axis, you will say uh, f3 minus f1 sine theta 1 plus f2 sine theta 2. राइट नाउ जब मैं रेडियल एक्सिस की बात करता हूँ then there is no ambiguity. The force towards the center minus the force away from the center is equal to m into radial acceleration always. लेकिन जब मैं टेंजेंशियल एक्सेलरेशन की बात करूंगा और टेंजेंशियल डायरेक्शन में हमारे पास दो फोर्सेस आ गए, तब हमें मालूम होना चाहिए कि बड़ा फोर्स कौन सा है. Right? So I'll put a mod here, and this is equal to mass into tangential acceleration. Right? अभी तक ये जीरो था, लेकिन अब यहाँ पे tangential acceleration आ गया. And the value of tangential acceleration is, हाँ पार देख मैंने लिखा है ना, या मॉड लिख दिया ना मैंने. मॉड का मतलब है कि आप उसको प्लस लेके उसको माइनस कर सकते हैं. आपको मालूम होना चाहिए कौन सी फोर्स बड़ी. So tangential acceleration is dv by dt. This is the rate at which the speed changes, or at is equal to r alpha. Okay? Is equal to r alpha. ये कैसे आया? I can always write dv by dt as d into r omega by dt, which I can take out r common because we know that r is not changing. So this will become r alpha. So here you can write this as m dv by dt, or you can write this as m into r alpha. Okay, so both the expressions you can use. Just like in radial acceleration, you have multiple expressions. In tangential acceleration, also you have multiple acceleration. So this is the difference that is going to come along. And then for the third axis, there is no change whatsoever. Summation of forces along the third axis must be equal to 0. Okay, this is the scheme of things that we are going to follow. How is this different? Well, it is different on two counts, both of which I have written here, but I want to highlight. So the difference arrives when you have this acceleration. When you have this acceleration, this tangential acceleration. And the difference arrives when here the velocity and the omega, they are not constant. So in circular motion, the magnitude of velocity of the particle is constant, and the magnitude of the centripetal acceleration or the radial acceleration is constant. Whereas in non-uniform circular motion, the magnitude of the velocity of this particle executing circular motion is not constant, and the uh, magnitude of the centripetal acceleration or the radial acceleration is not constant. Okay? This is what you have to remember. This is what you have to apply when we are doing questions. So please take a screenshot. I will move to the next. Please take a screenshot. I will move to the next. I will move to the next slide now. Okay. So a particle moves along a circle of radius r, starting from rest, yeah, with an angular acceleration alpha. Find the speed and acceleration of particle after time t. Okay, so I will solve this question. So we have mass of the particle is m. So we have a particle, maybe it starts from here, and then it starts from rest, and it goes like this. Angular acceleration alpha hai, so it keeps on accelerating, right? I hope ये सबको समझ में आया. I hope ये रेड डॉट का मोशन आपको दिखाई दे रहा है. ऐसे पार्टिकल मूव करेगा, तेज होता जाएगा, तेज होता जाएगा, तेज होता जाएगा. Right? This is what we mean by angular acceleration. So let's solve. I will put the particle here at some time t. This is the tangential and this is the radial axis. Third axis I cannot draw here, and I don't think I need it also. Tangential axis. Now, if the angular acceleration is alpha, okay, if the angular acceleration is alpha, then that's very nice. Yes, Vishwadi. Excellent, excellent, good. So if the angular acceleration is alpha and omega initial is equal to 0, then after time t, we will get omega is equal to alpha t. I cannot draw the third axis because I don't have a 3D pen. And even if I did have a 3D pen and I drew the third axis, I could only see it, you could not see it. I am drawing the third axis. दिखाई दिया? किसी को दिखाई दिया? किसी के स्क्रीन से बाहर निकला थर्ड एक्सिस? नहीं. Right? So this is a very genuine doubt, okay? A very genuine doubt. Let me clear it. Unfortunately, what is happening is that from the beginning, since we are working on the screen, or when we start with normal classes, we'll be working on the board, right? So our brain sort of, adjusts itself to 2 dimensions. And the moment we start to talk about 3 dimensions, there would be problems. So if I want to really talk about 3 dimensions, then this would be the radial axis, this would be the tangential axis, and this would be the third axis. Right. Now I can, of course, draw the radial and tangential and third axis here, but it will not always be possible, feasible or advisable कि हम थर्ड एक्सेस बना रहे हैं या तीनों एक्सेस बना रहे हैं रादर. कई प्रॉब्लम्स जो हमने लास्ट टाइम किया था, इफ यू रिमेम्बर, हम थर्ड एक्सिस और रेडियल एक्सिस बना रहे थे, टेंजेंशियल नहीं बना पा रहे थे. हॉरिजॉन्टल सर्कल में अगर कोई चीज चल रही है और आप साइड से देख रहे हो, ठीक है ना, हॉरिजॉन्टल सर्कल में कोई चीज चल रही है और आप साइड से देख रहे हो, तो ऑब्वियसली फिर आप टेंजेंशियल एक्सिस नहीं बना पाओगे. स्पेशली गाड़ी अगर एक एंड पे है, ऑब्जेक्ट अगर एक एंड पे है. But it is not to be, you don't have to worry about it, because पूरे मैकेनिक्स में तो हमने कभी तीन एक्सिस नहीं बनाई, तो यहाँ पे भी हमें तीन एक्सिस की जरूरत नहीं पड़ेगी, except in a very few, in a very small subset of questions the third axis will be required. Abhi I will give you one question where all the three axes will have to be drawn, right? So don't worry about it. Okay, don't worry about the fact that you cannot draw all the three axes, because you cannot. I mean, our brains have adjusted to this two-dimensional view of the screen or the two-dimensional view of the board when we start with normal classes. Okay, so if the angular acceleration is alpha and the initial angular velocity is omega I is equal to 0, then after time t, the omega must be equal to alpha t. So at this point, omega is alpha t. And we know that the radial acceleration of the particle is equal to omega square r. So this must be equal to alpha square t square r. Since this is non-uniform circular motion, there must be a tangential acceleration as well, and the tangential acceleration will be equal to alpha r. Right? So the question is asking me two things. First thing it is asking is the speed, and the second thing it is asking me for acceleration. So since after time t, omega is equal to alpha t, this implies that v, which is equal to r omega, will be equal to alpha r into t. Sorry. Will be equal to uh, will be equal to, नहीं सही तो लिखा ना मैंने, हाँ सही, will be equal to r alpha. This is the speed of the particle. Where is the speed? The speed is here. That's it. Tangential speed is here. What about the acceleration? Can anybody tell me the acceleration of the particle? Can anybody tell me the acceleration of the particle? It is there. I have drawn in the diagram. Very nice path. Yes, yes. Very good. So this is what I want you to remember what Parth has said. The net acceleration of a particle executing circular motion is the radial acceleration square plus the tangential acceleration square. Right? Remember that all I'm doing is finding the vector sum. So this will be equal to alpha square t square r whole square, right, plus alpha r whole square. Very weird, I know, but this is what the acceleration will be. So this guy is the radial acceleration. I can write. This guy is the tangential acceleration. this is what you have to sort of get a grip over, and that is that if you have non-uniform circular motion, then the net acceleration of the object is the vector sum of the radial acceleration and the tangential acceleration. Okay? बाकी सारे steps they remain the same. चलो, let's. I'll give you one question. Don't worry. Take your time. A car moves along a horizontal circular track. हाँ, मैं जा रहा था, एक मिनट. It starts from rest and moves with constant moves with changing speed. A is equal to dv by dt. If radius is r and coefficient of friction is mu, find the time at which the car will start to slip. Okay? चलो इसको करो. This is the previous question. Please take a screenshot. हो गया? Screenshot ले लिया? वेलोसिटी नहीं निकालना है। नहीं, गलत है ये। नहीं, गलत है ये। हाँ, सही है, पार्थ लंबा आंसर है। ओके, चलो, थोड़ा बहुत सही है ये। लेट मी show you how this is done. First, you must understand the question. So, what is the meaning of start to slip? Right? Good, Radhika. Yes. Yes. So, Biju, बहुत बढ़िया. So, yes, boss. Good. Start to slip. ये term जब भी आ जाए, और I think I've been saying this when we started with friction. Starts to slip, just moves, just does not move. इन सब का मतलब ये होता है कि फ्रिक्शन की वैल्यू मैक्सिमम हो गई है. ओके, सो द टाइम एट विच द कार विल स्टार्ट टू स्लिप का मतलब ये है कि हमें वो टाइम निकालना है जब ये कार और रोड के बीच के फ्रिक्शन की वैल्यू म्यू एन हो जाए. राइट नाउ let's go back to this. Let's go back to this diagram. So let's say that the car is here. This is the car moving along the circular road. And let's say further that the velocity of the car is here. Right. So basically what is happening is that this car is going round and round this circle. And since the car is accelerated, or dv by dt is equal to a, right? This implies that as time goes on, velocity keeps on increasing. But more than that, it means that v is equal to at at any time t, since the initial velocity was 0. Right? Coming back to the question, a car moves along a horizontal circular track. It starts from rest and moves with changing speed. A is equal to dv by dt. Okay. So back to the diagram. Let's draw the forces acting on the particle. First, out of the three axes, red, green, blue, which is the radial axis, which is the tangential axis, and which is the third axis? Out of the three axes that I have drawn, red, green, blue, which is the radial axis, which is the tangential axis, and which is the third axis? इसमें हम सबको clarity रहनी चाहिए. So the blue one is the radial axis, the green one is the tangential axis, and the red one is the third axis. Okay? अब mg किधर act कर रहा है? mg किधर act करेगा? Where is mg acting? mg किधर act करेगा? Very good. Yes, it will act along the third axis, and it will be downwards. Right? It will be downwards along the third axis. Let me just draw that here. ये रहा हमारा mg. Okay? Normal reaction किधर रहेगा? Where is the normal reaction on the car? Where is the normal reaction on the car? Where is the normal reaction on the car? Normal reaction. ज़मीन किधर है? Where is the floor? Where is the surface? Where is the surface? Where is the normal reaction? What is the direction of the normal reaction? नहीं. Normal reaction should be opposite to mg. Here it is. Here are now. Okay? Remember that the green blue, the green blue plane, this plane is the ground. So the normal reaction should be perpendicular to the ground. Normal reaction ऊपर जाएगा. If you are getting confused, this is north, this is east, this is up, and this is down. Like north, so that अच्छा. अभी अभी आ रहा है, क्लियर है सबको? ये mg नीचे रहेगा और नॉर्मल रिएक्शन ऊपर रहेगा. Is clear to everyone now? Okay. Now I ask the next question. बहुत बढ़िया बात. Yes. Now I ask the next question, and the next question is, what is the value of F applied? Because ultimately we are dealing with friction, right? And ये मैंने पहले बताया नहीं है, अभी बता दे रहा हूँ. And we are actually dealing with case 1. Now you may say, नहीं नहीं, ये case 1 कैसे हो सकता है? कार तो move कर रही है. But as we will see later on, not now, as we will see later on, if I talk about a moving car or a running man, okay, in both these cases, the case 1 is applicable. And the reason is, which we will discuss later in detail, the relative motion between the tires of the car and the road, or the relative motion between the shoes and the surface is not there. जब आप वॉक करते हैं या रन करते हैं, जब आपका राइट फुट ग्राउंड को हिट करता है, तो जब तक आपका राइट फुट ग्राउंड से ऊपर नहीं चला जाता, जब तक वो ग्राउंड को लीव नहीं कर देता है, तब तक राइट फुट और ग्राउंड के बीच में कोई रिलेटिव मोशन नहीं होता है. अगर रिलेटिव मोशन हो गया तो आप चल नहीं पाएंगे. यू विल फॉल डाउन एंड यू विल से दैट आई स्लिप्ड. In fact, this is what happens when you slip. In the same way, if the relative motion between the tire of the car and the road was there, then there would be a constant black mark, black streak on the road, because if the tire is having relative motion on the road, तो हिंदी में बोला जाए तो टायर हमेशा रोड पे घिसता रहेगा और उस पे वो ब्लैक मार्क आता रहेगा. नाउ द ब्लैक मार्क कम्स व्हेन, रिमेंबर, जब एक आदमी बहुत तेजी से ब्रेक मार देता है या एक आदमी बहुत तेजी से एक्सेलरेटर को दबा देता है. राइट? बोथ दीज केसेस स्लिपिंग अकर्स and you get those black marks on the road, skid marks on the road. So whenever we are dealing with a car traveling on a road or a person running on a road or ground, please remember that this is case 1 of friction. Okay, therefore to handle case 1 of friction, we need the value of F applied. क्या है भाई F applied? क्या है F applied? क्या है F applied? नहीं, no. F applied is the net sum of forces parallel to the surface in the absence of friction. अगर मैंने एक ऑब्जेक्ट का एफबीडी बनाया और उस पे फ्रिक्शन नहीं बनाया, बाकी सारे फोर्सेस बना दिए, now I find out the net force parallel to the surface, that gives me F applied. And in case 1, there were 3 scenarios. Okay? Scenario 1, the object is not moving and F applied is something. Okay? Scenario 2, the object is moving and F applied is something. Scenario 3 क्या था? What was scenario 3? Scenario 3 was that क्या? यस अभिजीत, यस। बाकी सब लोग भूल गए लग रहा है, सब लोग सो गए या भूल गए। Scenario 3 was when F applied is 0, then whatever acceleration that you see must be caused by. Scenario 3 was when F applied is 0, whatever acceleration that you see must be caused by friction, right? So in this case, F applied is 0. There is no horizontal force on the car. Okay? In the absence of friction. अगर फ्रिक्शन नहीं है यहाँ पे तो इस कार के ऊपर कोई भी हॉरिजॉन्टल फोर्स नहीं लगी है, क्योंकि mg तो नीचे की तरफ है, नॉर्मल रिएक्शन तो ऊपर की तरफ है, और सरफेस और अर्थ के अलावा इसके सराउंडिंग में कुछ है नहीं। तो सरफेस ने नॉर्मल रिएक्शन ऊपर लगाया, अर्थ ने एमजी नीचे लगाया, कहानी खत्म हो गई। लेकिन सरफेस तो एक और फोर्स लगा सकती है, वो है फ्रिक्शन। तो इसका मतलब इस कार का हमको जो भी एक्सेलरेशन दिखाई दे रहा है वो एक्सेलरेशन मस्ट बी ड्यू टू फ्रिक्शन। तो हमें इस कार का एक्सेलरेशन कहाँ और कहाँ दिखाई दे रहा है भाई? हमें इस कार का एक्सेलरेशन कहाँ और कहाँ दिखाई दे रहा है? हमें इस कार का एक्सेलरेशन रेडियल दिखाई दे रहा है। रेडियल क्यों दिखाई दे रहा है? क्योंकि ये सर्कुलर मोशन में है, राइट? लेकिन इसके अलावा हमें इस कार का एक्सेलरेशन टेंजेंशियल भी दिखाई दे रहा है। क्यों दिखाई दे रहा है? क्योंकि इसकी जो वेलोसिटी है वो समय के साथ चेंज हो रही है। This means that the net acceleration of the car that I see is here. This is the direction of the net acceleration of the car. And this net acceleration must be caused by what? This net acceleration must be caused by what? Must be caused by friction. Therefore, on this FBD, now I can draw the friction force. This is the friction force. And as promised a long time back, I told you that I will show you that not only can friction be opposite to motion, it can be in the direction of motion, which we have already discussed, but it can be perpendicular to direction of motion, and it can have any direction with respect to direction of motion. This is the case where it can have any direction with respect to the direction of motion. Velocity of the car is here and the direction of friction is here. Okay? अगर ये कार यूनिफॉर्म सर्कुलर मोशन में होती तो फ्रिक्शन किधर होता? अगर ये कार यूनिफॉर्म सर्कुलर मोशन में होती तो फ्रिक्शन किधर होता? अगर ये कार यूनिफॉर्म सर्कुलर मोशन में होती तो एक्सेलरेशन किधर होता? रेडियल, सेंट्रीपिटल, right? Blue line, yes, towards the center. So in this case, the car will have friction which will be perpendicular to the direction of motion. Now this is extremely non-intuitive. Okay, some of you, I hope some of you are saying ये क्या बकवास है, अगर कार गोल चक्कर में घूम रही है, हम तो गोल चक्कर में कार में घूम चुके हैं, फोर्स तो बाहर की तरफ लगती है, या अंदर की तरफ कैसे फोर्स लग रही है, राइट? Extremely non intuitive. You are absolutely right. I am absolutely right. How can this be? You are absolutely right when you say कि जब हम कार के अंदर बैठे थे और कार गोल घूम रही थी तो हमें तो आउटवर्ड फोर्स, आई होप एवरीबडी हैज एक्सपीरियंस दिस, और मैं बोल रहा हूँ कि नहीं नहीं नहीं, ये तो भाई जो फोर्स लग रही है वो तो अंदर की तरफ लग रही है, टुवर्ड्स द सेंटर लग रही है, राइट? You are right, I am right. You are right because you were a non inertial observer inside the car. You are a non inertial observer inside the car. And therefore, we will leave that discussion for the next class. From the inertial frame of reference, that means standing outside, okay, standing above the car, like God, ऊपर से देख रहे हैं हम, standing outside, I, as an inertial observer, will say that since the car is moving in a circle, the force on the car must be towards the center of the circle, right? यहाँ पे I like to do an experiment in the class. Now, obviously, I cannot अभी नहीं कर सकते हैं. The experiment that I do is very simple, and you can actually predict कि क्या हो जाए होने वाला उसमें. So what I do is I take the marker, and the marker is just like your pen. उसमें वो, you know, that projection is there, that slot is there, जिससे कि आप उसको पॉकेट में फंसा सकते हो, right? So what I do is that in the classroom I stop the fan, और जब हम वापस क्लास में चलेंगे तो I'll show you, we'll do this experiment. So we stop one fan in the classroom, and one person will take the marker and using that slot will fix the pen on one of the blades of the fan. Okay, and then I will switch on the fan. क्या होएगा? अगर मैंने मार्कर को या पेन को ब्लेड के आउटर एज पे, बाहर की तरफ मैंने फंसा दिया और उसके बाद से फैन को ऑन किया, right? You can try this. Well, I will not suggest that you try this at home, but when we are back in the class, we'll do this experiment. So the fan will start to rotate slowly. It will pick up speed, right? And the marker will be stuck to the blade of the fan. And at one point, when the fan attains a significantly large speed, when the blade attains a significantly large speed, right? Boom, वहां से निकलेगा, बहुत स्पीड में निकलता है. तो सब लोग कॉपीज को अपने मुंह पे रखते हैं ताकि जो है वो हाँ, moves tangentially outwards and it moves tangentially outward. क्या होता है? Radially outward and tangentially. What is happening? Okay? What is happening? When the fan is rotating and the pen is not falling down. Let me first address this case. Let's say that the fan has achieved its full speed, which is not very large. हमने fan का regulator कम कर दिया है और उसमें हमें दिखाई दे रहा है कि मार्कर गोल गोल घूम रहा है. तो मार्कर के ऊपर फोर्स क्या क्या लगी हुई है? mg is pulling it down, and therefore mg cannot be responsible for the circular motion. The normal reaction is vertically upwards, and therefore that also cannot be responsible for circular motion. So the only force that is responsible for circular motion of the marker is friction. Okay, it is because of friction that the marker is going round and round. And we may choose to call this friction force the centripetal force. This is what I want you to understand, learn, remember, that out of the five forces, out of the five objects in the surrounding that we have seen, so six forces, mg, uh, normal reaction, friction, टेंशन, स्प्रिंग फोर्स, एक्सटर्नल एजेंट, यही छह फोर्सेस में से एक या एक का कंपोनेंट या दो का कंपोनेंट, यही सेंट्रीपिटल फोर्स बनते हैं। लास्ट टाइम हमने क्वेश्चन किया था, एक एक क्वेश्चन में नॉर्मल रिएक्शन ही सेंट्रीपिटल फोर्स बन गया। अगर मैं रस्सी से एक पत्थर को बांध के घुमाऊंगा गोल 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 गोल, आई होप सबने ये किया हुआ है एट सम पॉइंट ऑफ टाइम इन योर लाइफ, तो जो टेंशन है वो सेंट्रीपिटल फोर्स हो गई। और अगर आपने मनीष ने मुझे खांसी दे दी है, मनीष कल मनीष के सामने मास्क मैंने उतार दिया। तो if you put the marker on the fan, then the centripetal force is now the friction force, right? मजाक कर रहा हूँ मनीष, मजाक। So friction has a maximum value. We know this, right? Friction has a maximum value. And if I rotate, or friction is responsible for rotation of the object, and friction reaches its maximum value, then that is the limit of the rotation that can be caused by friction, right? तो जो लोग बाइक चलाते हैं और बड़ा हीरो बन के, they negotiate a turn, and they think they are looking very smart, and they negotiate a turn by driving very fast. So the problem is that if we consider uniform circular motion, the problem is that the centripetal acceleration is v square by r, and we know that the maximum acceleration that friction can provide is mu g. याद है ना, सुपरमैन के shoes. So if mu g is equal to v square by r, then you have reached the limit. इससे ज्यादा फोर्स फ्रिक्शन प्रोवाइड ही नहीं कर सकता, या इससे ज्यादा एक्सेलरेशन फ्रिक्शन प्रोवाइड ही नहीं कर सकता। लेकिन एक्सेलरेटर तो वो जो बाइक चला रहा है उसके हाथ में है, एंड ही वांट्स टू लुक इवन मोर कूल, इवन कूलर। तो उस बंदे ने क्या किया कि एक्सेलरेटर और घुमा दिया। जब एक्सेलरेटर और घुमाया तो उसकी स्पीड बढ़ गई। लेकिन v स्क्वायर बाय r, ये जो रेशियो है ये तो कांस्टेंट रहना चाहिए, ये चेंज नहीं हो सकता, क्योंकि ये अपने मैक्स वैल्यू पे पहुंच गया है। तो अगर मैं v को इंक्रीज कर दूंगा तो क्या होएगा? अगर मैं v को इंक्रीज कर दूंगा तो क्या होएगा? v square by r must be a constant. v square by r must be equal to mu g, उससे ज्यादा हो नहीं सकता। मैंने v को इंक्रीज कर दिया तो r के साथ क्या होना पड़ेगा? What will happen to r if I increase v, and v square by r must remain constant? क्या हो गया भाई तुम लोग को? r क्या करेगा? r इंक्रीज करेगा ना। एक फ्रैक्शन में अगर न्यूमरेटर को इंक्रीज कर दिया, फ्रैक्शन को मेंटेन करने के लिए डिनोमिनेटर को भी इंक्रीज करना पड़ेगा ना। तो v स्क्वायर अगर इंक्रीज हुआ तो r भी इंक्रीज हो गया। r इंक्रीज हुआ तो you have to go along a circle which is having a larger radius, and therefore what will happen to the bike? It will go along a circle of larger radius. But of course that will come as a surprise to the idiot who is driving the bike. And we will, in physics, we will say that slipping has occurred, and the person who is driving the bike will say, "Oh, galti ho gaya, jo bhi, I don't know what that guy will say." So friction, whenever it is responsible for circular motion, there is an upper limit, right? In uniform circular motion, this upper limit is easily recognized. It is simply mu n is equal to mv square by r. But in non-uniform circular motion, थोड़ा सा और complicated हो जाता है friction because this friction must be equal to m into a net. Okay, and I'll just go back to that page. So F is equal to m into a net, which is equal to m into root of ar square plus at square, which is equal to root of uh, m into root of v square by r whole square plus a square. Right? A is dv by dt, so that is the radial acceleration, right? But v is equal to a t and f is equal to f max is equal to mu mg. Therefore, we get mu mg is equal to m into a net, which is equal to root of v की जगह at डालेंगे तो मेरे पास आएगा a square t square by r whole square plus a square. M and m cancel out, right? And again, you can see the relation, which is now, I hope, stylus. So now you'll get mu g is equal to root of a power 4 t power 4 by r square equal to plus a square. And we had to find t. Please notice that अब ये चीज जो है ये आ गई हमारे पास a max which is equal to mu g, right? ठीक है, t की वैल्यू निकालो, बताओ मेरे को t की वैल्यू. So t will be some weird. T will be equal to mu square g square minus a square into r square whole raised to the power 1 by 4 whole divided by. Okay. नहीं भाई अथर्व, फ्रिक्शन हमेशा टुवर्ड्स द सेंटर कहाँ है? फ्रिक्शन टुवर्ड्स द सेंटर कहाँ है? फ्रिक्शन तो ये रहा ना, एफ की वैल्यू है ना यहाँ पे, ये देखो एफ किधर है. अगर हमारे पास ये एंगल थीटा है तो इन दिस केस tan theta will be equal to a radial upon a tangential, which will be equal to v square by r upon dv by dt or v square by r upon r alpha. ठीक है, फिर ऑपोजिट होना चाहिए। तो भाई ऑपोजिट होना चाहिए तो फिर एक्सेलरेशन कौन कॉज कर रहा है भाई? यही चीज तो मैं एक्सप्लेन कर रहा था ना पिछले चैप्टर से। फिर आप 10th वाले मोड में आ गए, फ्रिक्शन किधर होएगा? बैकवर्ड। बैकवर्ड वाली कहानी बताई थी ना मैंने। प्लीज ग्रो आउट ऑफ दैट। फ्रिक्शन डज नॉट अपोज मोशन ऑलवेज। In most of the cases, friction is actually responsible for motion. In this case, the motion of the car is due to friction. Because friction is at an angle from velocity, therefore friction has a centripetal component. One component of friction is centripetal. One component of friction is providing the centripetal force responsible for the circular motion of the car, and one component of friction is providing the tangential force, which is responsible for the increasing velocity of the car. Okay? Okay? Chalo, so I think I'll stop here, and we have to maths का class होएगा. So I'll see you in the next class. Centrifugal force next class में विश्वजीत, अभी नहीं. Now, please attempt HCV very sincerely. ज़्यादा questions नहीं हैं. Please try to finish. Last के 4-5 questions छोड़ के, last के 4-5 questions centrifugal force से होंगे, which I will do in the next class. Okay, next class में we'll finish this chapter. चलो, okay. Vertical circle पार्ट जब हम वर्क एनर्जी करेंगे तब करेंगे, ठीक है? हाँ हाँ, ओके. चलो, बाय बाय. नेक्स्ट क्लास में मिलते हैं फिर. पहले मैं होस्ट बना दूं, मेक होस्ट.